The first thing that we need to be able to know is what a cubic graph looks like. It's a cubic equation if the power is 3, okay? So what we want to do, like we usually do, is substitute these values into x. So for the first one, girls, if you make sure you put in a bracket, if you cube minus 2, you're going to get minus 8. You know how to do this, so I'm just going to do the answers, okay? You're going to get that. All right, so if I plot this out, so minus 2 goes down to minus 8, so that's like here. Minus 1 goes to minus 1, 0, 0, 1, 1, 2, 8. Okay, it's going to look like this. Okay, so girls, this is your basic cubic graph that you need to memorize. Now, like we did for parabola, girls, listening, we're going to learn to translate this graph. So girls, same thing, but if it says minus 2, it just means you're shifting the graph down by 2 units. So instead of being at 0, 0, now it's going to look like this. Okay? Same thing, if it was plus 2, what do we do? Move the graph up. Okay? Okay. Girls, one extra note. If I were to be thorough and I wanted to know what that x value is, so from here, girls, if I want to know what the x-intercept is, what will I need to substitute in here?
0 as y.
Yeah, so substitute 0 as y. So if I do 0 is equal to x cubed plus 2, girls, you know how I then get x cubed is equal to minus 2? Yeah? Girls, you can cube root a negative number. So don't think you can't solve it. You can cube root negative number, and it does not come with plus or minus. Okay, you can do that. That's what I wanted to show. And if you put that in the calculator, you're going to get minus 1 point something, 1.5 or something, 1.3. Okay? So, yeah, you can cube root negative numbers. Now, from the same cubic graph, okay, let's sketch the rest. So from here, that looks bad. That's all right. If there is a minus in front, girls, what do you think it's going to look like? It's the other way. Okay? You know how when we had, girls, when we had that, it was like this. And when there was a minus in front, we did it the other way around? Well, with cubic, it's reflected the other way. Okay? As usual, girls, from the minus x cubed, if I plus 1, it's just the same purple graph, but shifted up by 1. So it's just going to look like this. Okay? Let's do the same thing if the numbers get bigger in front of the x cubed. So once again, if there is a number 2, remember this is a 1 right now. If the number gets higher, what happens to the parabola if the number gets higher? Yeah, same thing applies for cubic graph. But girls, like I mentioned, you don't want to just draw a narrow graph and show that's how the graph looks like. Show me some detail. And girls, the point that you usually want to use for cubic graph to show how narrow it's become is actually 2, not 1. Okay, because we use 1 for parabola. So if I substitute 2 into the original, what is it? What's that? 8, yeah? So it's not to scale, but obviously, girls. So for a normal cubic graph, the coordinate you can show is 2, 8. But for this one, you still pick 2, but let's see what y looks like if I substitute 2 in here. So I'll do the working out here because I'm running out of space. So you got 2 times 2 cubed, and what's that? 2 times 8? 16. So what I've shown is like all the way up here. Okay, so usually use the coordinate 2 to find how narrow it's become. See how we've got 16 here, but we have 8 before? So it's doubled in value, which makes it narrower. Same thing if it's a half. If it's a half, the graph becomes wider because the number's gone smaller. Once again, from 2, if I substitute 2 into the equation, girls, what's that? Half times 8? 4. Okay. My graph is completely out of scale. Yeah, so look, I'll just draw a better one. Okay, yeah, so that's meant to be 2, 4. Okay, so girls, as you can see, girls, the y values have decreased if the number has decreased in front of x cubed. All right, girls, sometimes what they'll do is they'll give you the graph, listening, and they'll ask you to find the equation in this form. Okay? Girls, firstly, that c is the y-intercept, the number without x. Girls, what's the y-intercept in this graph?
Minus 3.
Minus 3. So girls, That's minus 3. So what I'm going to do is I'm going to rewrite this with y. So y equals to x cubed minus 3. Okay? Now, we need to find a now. So find a by using the coordinate now. Okay? So so this is your x, this is your y. So my y is 12, and a x cubed, that's a times 2 cubed, minus 3. So from here, you want to solve for a. What's that, girls? 8a minus 3, and the rest is history. So bring minus 3 to the other side, 15. So a is equal to 15 over 8. You can't leave it like that. So girls, listening, my final equation is y is equal to 15 over 8x cubed minus 3. Okay, so they will sometimes ask you that. All right, girls, this is your basic introduction to cubic equation. Now later I'm going to show you how to graph equations when there are 3 brackets, and this is still a cubic graph equation. You'll be doing this in extension 1 polynomials, but I thought I'd show you how to do this a bit later after you've done some questions first. Okay, so second half of the lesson I'll be showing you how to do that, which is a little snippet of the question that I pasted on your exercise, if you can see in the corner. That's straight from the Year 11 extension 1 book. So I'll be showing you how to graph that later.